Hello students, good morning. In the previous period, we have seen the successive differentiation of a function. Now, in this period, we will see how to determine the total differentiation of a function f. Let f be a function of two independent variables x and y. Let us assume that the values of independent variable changes from x to x plus delta x and y to y plus delta y, where the corresponding changes in f is f plus delta f. Then we can write the equation of a function f is equal to f of x y. Now, putting as x changes to x plus delta x and y changes to y plus delta y, and f changes to f plus delta f. So, the above equation becomes f plus delta f equals to f of x plus delta x, y plus delta y. Taking the difference of above equations, we get f is equal to f plus delta f minus f. Therefore, delta f equals to f of x plus delta x, y plus delta y minus f of x y. From equation 1, we see that f can be substituted by f equals to f of x y. Adding and subtracting f of x, y plus delta y on the right hand side of the equation 2, we get delta f equals to into the bracket f of x plus delta x, y plus delta y minus f of x, y plus delta y bracket close plus in the second bracket f of x, y plus delta y minus f of y. On right hand side of equation 3, multiply and divide by delta x to first bracket and by delta y to the second bracket, we get delta f equals to into the bracket f of x plus delta x plus y plus delta y minus f of x, y plus delta y bracket close divided by delta x into delta x plus into the another bracket f of x, y plus delta y minus f of x y divided by delta y multiplied delta y. Now, we consider that the increment delta x, delta y are very small. Therefore, they can be written approximately as a delta x equals to the dx and delta y equals to dy, delta f equals to the df. And thus, when delta x tends to 0 and delta y tends to 0, the equation 4 becomes delta f equals to limit of delta x tends to 0 into the bracket f of x plus delta x, y plus delta y minus f of x, y plus delta y bracket close divided by delta x into dx plus limit of delta x tends to 0 into the bracket f of x, y plus delta y minus f of x y divided by delta y into dy. This is equation number 5. By using the definition of partial differentiation, we get df is equals to dou f by dou x into dx plus dou f by dou y into dy. That is, df is equal to f at x dx plus f at y dy. This is equation number 6. The equation 6 represents the total differentiation of two independent variables x and y. If the function f equals to f of x, y, z, where x, y, z are three independent variables, then its total differentiation df can be written as df is equals to dou f upon dou x into dx plus dou f upon dou y into dy plus dou f upon dou z into dz. Therefore, df equals to f at x dx plus f at y dy plus f at z dz. This is equation number 7. This equation is applicable to the function of any number of independent variables. This is the total differentiation of the function. That's all. Okay, thank you.